Hey, got it, Dan. Thank you very much, and good evening to everybody. I'm Randy Smith, Whiskey Uniform 2 Sierra, member of the Arden Project, president of Amateur Radio Emergency Data Network, 501c3 charitable corporation we set up to support the project. And you should all see my screen. Can I get an okay? Dan, is that okay?
Yes, it is.
Okay, very good. Thank you. So we'll, let's get this going here. Okay, so thank you for the opportunity to speak to all of you this evening. I'm just going to cover an overview of what the Arden project is and how you might use it and why you might use it. There's an awful lot going on, and I'll say this now and I'll probably remind you at the end. There are several good sources to follow up to get additional detail. One, of course, is our very nice website, and that's ARDENmesh, AREDNmesh.org, ardenmesh.org. It's a very active website, and there's a lot of information out there, including a lot of documentation, as you'll see in a slide coming soon. And the second thing I want to mention is we've just started organizing a very large virtual conference, probably be an all-day Zoom conference on Saturday, October 24th. And we're going to put out a call for papers, call for presenters very soon. But we've already got the basic lineup going, and we'll fill that out as we get going. My friend from Southern California, Orv Beach, Whiskey 6 Bravo India, one of our premier Arden ambassadors, is organizing that for us. So look forward to that October 24th. There's a bit of information on the website now. So we're going to talk about high-speed multimedia mesh network, how to keep the data moving when your lights go on. And I usually start by asking people, how many of you have used microwave radios to send data? And a lot of people say, no, gee, I don't know what you're talking. I don't have any big dishes. I use HF, and I'm a CW operator, or I'm on the VHF and UHF bands. But of course, if you look in your pocket or on your desk, I would guess every one of you has operated microwave transmitters, either your smartphone or your home Wi-Fi or Wi-Fi in the office. And the reason that this comes up is that what we're doing is functionally no different from any of those things that you're already familiar with. But we'll talk about the differences about what we're doing and why we're doing it and how we're doing it to some extent. But most importantly, we'll try and answer the question, why bother with this? What can I do with all of this technology? So first off, let's answer the question, what's an Arden mesh network? Well, you're already familiar with, I'm sure, the internet technologies. We've got wires strung all over the globe and fiber optic cables. And so everything that we're doing in Arden works exactly the same way. It's all the same protocols. It's all open source stuff. And the only difference really is that instead of having copper wires or fiber optic cables between locations, we've got an RF link. And again, not too, not too real high tech or unfamiliar to most people. If you think back in the 60s and 70s, and I believe through the 80s, most of our long distance telephone communication through AT&T long lines, at least across the East here and certainly across the Midwest that I'm familiar with, there were microwave towers every 40, 50, or 60 miles or so. And you'd see them occasionally out in the cornfields or someplace. So same kind of thing, long distance links, radio, microwave radio, and that's what we're doing. We're using standard proven internet protocols to connect devices. So in your home or your office, you're familiar with a wired or a wireless or both setup where you've got devices connected to a router. You may have a firewall and then a connection to the internet to some external domain. And you can send packets of information from one device to another or from a device or your phone out to the internet and get an answer from some server somewhere out on the internet, maybe your bank, maybe Amazon. Well, an Arden mesh network really just extends that concept. We can extend out from an existing network or build a completely separate sort of private mini internet for ourselves, just connected with wireless mesh radios that you see here. And we might set this up to benefit, let's say, a hospital that wants to send some emergency traffic to a command post or a county EOC or something like that. Or we might extend it to a Red Cross shelter site and they need to send some information back. And of course, in today's world, almost all first responders strongly prefer using high-speed digital communications. They send their messages, their requests, their responses, typically via some sort of internet connection. Their dispatches are done that way, their logistics are done that way. So that's what goes on in the real world. To the extent that amateur radio has a role in helping responders putting up a high-speed mesh network like this that supports their existing traffic is a good thing for all. So let's talk briefly about what is Arden. Well, first and foremost, it's a collection of software. It's all open source, it's all freely available. It's licensed under a typical open source license, GPL version 3. It's agile, we have a flexible development model. It's very actively developed, as we'll talk about a little bit more in just a moment. We've also got a very active community of supportive people. There are over 2,900 people registered on our website, and we're getting dozens, if not hundreds, of questions and answers every week on the websites on all sorts of topics. All of our developers also are implementers, so it's not just somebody in a corner somewhere developing this code. It's people that are interested in focusing on and supporting first responder communication or emergency response communication. And as I said, it's active. We have what we call nightly builds. They're improvements, maybe bug fixes, maybe feature additions, maybe an introduction of a new piece of hardware to the supported hardware group. We call them nightly builds. They're not every night, 7 days of the week, but they do happen overnight. And lately meaning over the last 8 to 9 months or so, the nightly builds seem to be occurring at least once a week, sometimes twice a week. So that's in between what we call a stable release. There's updated software available. Arden is also a wireless mesh network. We're repurposing commercially available wireless internet service provider routers and radios, and we repurpose them so they can operate not only in the Part 15 spectrum that they were originally designed to, but a certain group of these radios can be also made to be operated correctly in the ham part of the spectrum that's often adjacent to the Wi-Fi spectrum. We support up to 144 megabit per second links, and that's been demonstrated in the real world. And of course, you would be operating these under Part 97. All you need is a technician's license. And there you see the current list of our team members. So how would I build a mesh network? Well, our standard reference model is a three-layered model, but you can do this any way that you like. And I'll start at the probably the opposite end from way most people start, which is in their home with just a couple of nodes. But I'll do that for the reason of getting you to think a little bit further into the future, that if you get involved with this, you may want to think, well, how do I support my community, and what kind of planning do I need to do? And we'll see some real world examples of that in a minute. So our first reference layer is what we call a backbone, and that's our high-speed, long-distance links. Again, think of this as the equivalent of the old AT&T long lines with their microwave towers going transcontinental and being able to route all those phone calls across. So for this, you'd want to have access to high points, mountains, water towers, the top of buildings, and you'd probably want to use high gain dishes, and you'd probably want to use the 3.4 gigahertz or 5.8 gigahertz channels that are available to connect these high-speed, long-distance links. The middle layer we'll call relay nodes, because they would connect our backbone links to downstream or deployed nodes. So they're also going to often sit on higher locations, maybe not the very highest, but they'd be somewhere in the middle, and they're sort of the intermediate between the very long distance links and then the populated areas that you want to be able to connect to. And there's a variety of equipment that you can use to achieve that. We recommend using tools like Radio Mobile and others to determine what locations you'd want to put your gear in. And finally, at the deployment layer, you'd have some very inexpensive gear that might operate on the 2.4 gig or 5.8 gig bands, and they may or may not also provide Wi-Fi access. So somebody, say in a Red Cross shelter, might be able to use their own personal cell phone to connect to a Wi-Fi access point that you've set up that also connects to the mesh that you've set up. And they might be able to make phone calls or access information that way. And of course, these things might be operated off a car battery or some other 12-volt battery or a solar panel. You might even suction cup mount some of these nodes to a car window or a building window in an appropriate place. And we'll see a couple of pictures of those in a bit. So here's, again, a graphic example of our reference architecture, the backbone node and the relay nodes and the deployment nodes. So we'd be connecting a hospital or the point of delivery or an EOC from one place to another, a shelter to a command post, something like that. Some of these locations, almost certainly the backbone nodes and most of the relay nodes would be in fixed permanent locations, but they don't have to be. And often your deployed nodes might be temporary, or they might be on buildings, let's say permanently deployed on the roof of a high school that may, in bad conditions, be used as the local Red Cross shelters. So you might have permission to put up a permanent set of nodes there and then occasionally use it to test it. And here again, we'd see a recommendation for using, say, 3 gig on the long distance node, or 5 gig would be suitable as well. So let's talk briefly about why Arden at all. And well, we've got 4 good reasons, we think. It's very actively supported, it's relatively low cost, it's easily deployed, and it's easily maintained. So let's talk about active support. We've been at this now, and we grew out of working with and familiarity with the broadband ham net that you may remember that used the old blue and black little Linksys home routers that a group of very innovative hams figured out how to use and put into a mesh network. And that was, and we started with that. And then in 2015, we spun off of that and started Arden because we wanted to focus on a slightly different, more robust set of equipment, and it had a bunch of other ideas for extending its utility. So since the beginning of 2015, we've been working steadily at this. As I mentioned, we've got a very active community support from over 2,900 registered people. There are frequent software updates that fix bugs, they add features, they support new hardware. And as you can see here from the statistics, we've been maintaining our activity. And this is just an example from over the past year. And even just in the past few months, we've added a lot of improvements. Also, support that you're going to need is documentation. Our resident documentarian, Steve from Arizona, KC0EUW, has done an excellent job on building and growing and maintaining our documentation library. And you can get that off our website. You can even download the document as a PDF, so you can read it at your leisure or print it off or whatever you'd like to do. And I mentioned Orv before, our conference organizer. He's got wrote a beginner's guide that's helpful. And we've got installations worldwide. This is a sort of a rough location map from probably from last fall. It's improved a bit since then. We'll look at a little more of that, but there are hams all over the world. With at the moment, the exception of South America, at least there's none registered that I know of, but I know we've talked to people there. This is a slightly more detailed example of what's going on in Southern California, and we'll talk a little bit more about that in just a minute because it's extremely active. So there are links all over the 8 or 9 lower counties of California that connect not only hams, but municipal, county, and state level EOC sites and some hospitals and a few other Red Cross locations. So there's a lot going on there on all 3 bands. Another reason about Arden, why it's low cost. Most of the equipment that you'll deal with is, or you might consider purchasing, is fairly inexpensive. For the long distance stuff, I'll mention the bottom left corner. There's an item called the Rocket. It's only $80, but it's one of the pieces of equipment that does not come with its own built-in antenna. So you get your choice of antenna, and you can attach it to a sector antenna similar to the sector antennas you see on the tops of buildings for cell phone, or you can attach it to, there's a dual polarization omni antenna, or for your long distance links, you'd probably want to attach it to a particular dish. And those dishes are typically more expensive. So that'd be in the area of $250 or so, something like that. But to start out, just getting familiar with Arden, what we recommend for a lot of people is picking up 2 of those Microtech HAP AC light units. And let's see if I have one here. We'll have a picture of it in a minute, but they're only $54 or so a piece. And with these 2 units in your own home, in your own shack, you can get started and get familiar. You'd have a little 2-node mesh network and see how things work. There's a couple of other, the other two manufacturers that we support are GLINet. These are little sort of portable travel devices. They're really only for indoor only, and they're only on the 2.4 gigahertz band, but still people like them for a variety of reasons. There's a large number of use cases for them that are quite interesting. And then TP-Link makes a variety of weatherproof gear on 2.4 and 5.8 gigahertz. And those prices are also comparable to the Ubiquity gear, the nano stations. So they're typically in the $50 to $80 range as well. And here's kind of what they look like. There's a Ubiquity nano station up in the top left. The Rocket is the middle two things with the little two SMA connectors at the top. You see a sector antenna to the right of that. Microtech has a surprising variety of pieces of gear, including the first one on the left there, which is a light dish feed, LDF, which is real helpful because it doesn't come with the reflector dish, but what you do is you attach it to an old used Dish Network or Comcast or whoever else's used dish that you can find, and now it becomes your homeowners association stealth mesh network device, so you wouldn't get in trouble with an HOA. And TP-Link makes a variety of similar looking units as well. Our project manager, Andre Hansen, K6AH, put together a device selection guide here, a little spreadsheet that's available on our website. And this we recommend you look at in making your purchasing decisions, because you'll get some idea of what bands the devices cover, what kind of antennas they have, what kind of gain, and what sort of use case they're recommended for. So it's worth taking a look at, help you out with your planning before you spend any money. This is what the little $54, $55 Microtech HAP AC light looks like. In some ways, it's the equivalent of the old Linksys because it's got the little Ethernet ports, the switch on the back there. But in another way, it's not. It actually has dual radios in it. It's got a 2.4 gig radio in it. And that's the side that you can use as the mesh network. That'll connect to another 2.4 gig node in the mesh. And then it's also got a 5.8 gig radio in it. And that's the one that you set up as your access point. So if you want to use, let's say, your smartphone across a mesh to connect to another telephone system, or you want to use your smartphone and its web browser, or you want to use your laptop and its web browser to connect to some other thing somewhere else on the mesh network, you can set this up with your own SSID and say, oh, all I have to do is connect my phone or my laptop through this the 5 gig side of this HAP AC light, and then it'll route the traffic to the 2.4 gig side, which then connects to the mesh, and away we go. So again, starting with a pair of these, you're very versatile. You can learn an awful lot with a very small investment of your money. Another quick example here, the Microtech Lighthead grid. This is it's got sort of a plastic mesh reflector on it. And again, it's not very expensive. It may not be suitable for all locations because it is a grid. It's not a solid dish, and there is no radome for it. So it's not recommended for places that are going to see a lot of ice and snow, which will accumulate on that grid. But if you're in a relatively dry location, the high desert, someplace like that, or in an area that doesn't see a lot of snow and ice, it would be fine. Or for deployments in clement weather. Here's that LDF, light dish feed that I mentioned, our homeowners beater, homeowners association beater that you attach to a dish that you supply, and then it looks just like everybody else's satellite connection. And this is another newer Microtech device. It's about a foot square. It's a little bit higher power than the other devices that we've seen, and it's at a reasonable cost, and it's got a fair amount of gain as well. Let's talk about another aspect of Arden. It's easily deployed. So unlike the old AT&T long lines or even some of the other microwave devices that you see at ham contests, there is no coax cable for the data to get to the actual radio and then out into the dish or the whatever antenna you're using. Power and data go all up one Ethernet cable. It's power over Ethernet. That's PoE. And in fact, inside each of these plastic boxes, I remind people, it says the radio is almost an afterthought. There really is a very tiny but very powerful Linux-based computer inside these things doing a whole bunch of stuff, and attached to one side of the Linux computer is a couple of radios and a couple of power amplifiers, and all this is on one circuit board. And then of course then the power amplifiers then feed the attached antenna. They're typically fed with 24 volts DC, but they will operate successfully from 12 volts DC. Some of them will operate as low as, I believe the limit was 10.8 volts. So you can operate them from car batteries or whatever other 12 volt sources that you would normally use. And they are lightweight and rugged. Most of these units are under a pound and a half, something like that. And here's a couple of quick examples of deployment. On the left, we see what's been going on around Salem, Oregon, and their small network that covers parts of the valley and then across the width of the valley. Another similar small example is in and around the Dayton area, and there's a fairly active group of people in southwestern Ohio that are keeping things going there. It's the Miami Valley Mesh Alliance, and we've worked with them at our booth at all the previous hamventions. So they've been very helpful, and they're having a lot of fun. Here is another more detailed look at that very large deployment that I was referred to earlier in Southern California. There's around 450 nodes and some 1,200 or so active pathways and going across. And this is all deployed today. It's virtually all permanently installed, and the hams that own and operate this stuff are actively supporting it. We'll see a little bit more about that as well. The gear itself is easily maintained. It's all designed and built to sell to commercial wireless internet service providers. It's not designed and built to sell to hams, because if it was designed to to sell to hams, they wouldn't be selling much gear at all. So we're buying a couple of units at a time. The commercial installers are buying this stuff by the pallet load. So we get the benefit for this. And one of the benefits is that the gear itself is designed to be outside in the weather for years and years without failures. So that's a big help to us. Software updates from Arden are easy. They're pretty much select what you want to put there and click on it. Unlike the very early days in 2015 and before that, you don't actually have to physically travel to remote sites to update. You can do these over the air again, provided you got some, reliable links, and you may have more than one RF link between your endpoint that you're updating and your location that you're updating from. And we also provide a variety of tools that people have used to monitor the signal to noise ratio and network performance and a variety of other characteristics, help you not only maintain in the individual units, but across the network as a whole. Just a very quick look at, again, the Southwestern Division. This is a slightly less busy map of all their deployments, but a more detailed look. This is just the 2.4 gigahertz nodes. They've got quite a few of them in the populated areas. The 3.4 gigahertz, not as many, but they're in the high locations. They cover more of the long distance links, and then of course the 5.8 gig, and this is a band that's growing in popularity, and we'll see a lot of expansion of it over time. Here's an example from the real world. This is put up by my friend and lead developer on our team, Joe Ayers, AE6XE, and this is his Saddleback Peak deployment out in the high desert. He's got 3 sector antennas there, one on 3.4, one on 5.8, one on 2.4. He's got a pan tilt zoom camera mounted above the middle sector antenna, and on top of that camera is an Arden approved, Arden tested Marie Callender pie dish to keep the hot sun off the camera, and it works just fine. And if you notice in the lower right corner of that picture, there's an outdoor thermometer, and that's what Joe uses the camera for, to see how hot it is there. It's also fed by the solar panel, and there's several car batteries in the NEMA box underneath the solar panel. And this is all literally out in the middle of nowhere. Joe and his friend backpacked over many trips, all this gear up a mountain trail and out into the middle of nowhere to deploy all this. It's on ground owned by the county sheriff, and they've had permission to do this, so it's not a problem. Here's some other typical examples of deployment, usually for backbone or relay nodes. These are on some commercial towers in Southern California. It gives you an idea of what hams are able to do when they set their minds to it. And speaking about what can I do with it, well, what can I do with it? If you've gone to all this trouble, learned what to purchase and got the gear, got familiar with it, all of it at the end of the day is useless without applications and a reason to provide some communication services. And I think the message is you want to be able to help as an emergency communication responder to help your served agencies get through their first 49 hours when the emergency strikes and these local cell phone towers are overloaded. They may still be physically working, but the circuits are all overloaded, or actual the lines are down. But everybody has a need to get the high-speed data through. This is the service that you can provide. And there are things that people are already familiar with. You've got keyboard chat communications. So instead of talking over radio where everything can be overheard by people next to you or in a shelter, you can communicate keyboard live messages, or of course the equivalent of that you're gonna hear from the WinLink people tomorrow. The wonderful application you can use across Arden mesh just as you can across HF or anything else, or any other variety of email like services. There's computer aided dispatch applications. You may have heard of TicketsCAD. People are using that, and other services. Just a basic web server or file sharing, being able to provide access to documents like material safety data sheets and Red Cross recommendations, and maybe spreadsheets with logistics and orders for various supplies are easily done just as you would with any other internet service. Voice over IP telephony is very popular, and for good reasons. We really don't need to train anybody to use a telephone. So once you set up a communication network using Arden, and if you have a specialist that can run a telephony system for you, you can put a telephone in front of a Red Cross shelter manager or a staffer and give them a little card with, here's the various numbers you need to dial to get to the EOC or your command post or logistics to order various things, or the hospital or the ambulance corps. Anybody can use a telephone. So you can just set it up and walk away and make sure it's running and stay out of everybody's way and let them do our job. We've got a very excellent Arden ambassador, Mark Herson, N2MH, who's also here in New Jersey, not far from me. And he is our resident voice over IP telephony expert, and he helps out a lot too. Videos are very popular. We've got people doing a lot of streaming video. You may have seen on YouTube some of the videos that Orv Beach, W6BI, who's our resident camera expert, and others have put together on the various fires in California that we've seen last year. There's some examples of that out there, and that's helped. Blue Iris is one of the applications we recommend people consider, because it's very versatile for managing a huge variety of cameras, both fixed and pan, tilt, and zoom cameras. But there are others, and they're listed here. This is a very quick example of a real life reoccurring event and relationship that Arden mesh networkers in Southern California have with the Sheriff's Department, who oversee public safety for the annual Swallows Parade in San Juan Capistrano every March, I believe it is. And this is the Sheriff's Department Mobile Command Center. The television screens that you see in the background are being fed by cameras that the Arden mesh networkers set up just in advance of the weekend. So this is a temporary deployment, and they ran several chains of mesh networking and 4 or 5 cameras over key points that the sheriff wanted to monitor. And one of the sergeants from the that was assisting with the parade complemented what the hams were able to provide. So it really saved them a lot of effort and time, gave them a real good sense of being able to perform their public safety role as they needed to, with additional resources that they wouldn't have expected or wouldn't have been able to command out of their own budget. Here's Orv, W6BI, installing a permanent camera and some lessons that he's learned, and things that you can quiz him on. And I'm hoping that he will give a talk on this at our October 24th conference on the air, about setting up pan, tilt, zoom cameras and configuring them and managing them and what else you need to know. So he's quite a genius when it comes to that. And that picture in back, one of the things he learned is that the original Rome 25 tower that he had there shook a lot in the Santa Ana winds that they get in Southern California. And so he and one of his friends installed the additional a couple of struts there that you see on the right to stabilize the tower. It's just something that you have to learn from experience. Steve Ford from the League also pays homage to the notion of a mesh network. Makes it ideal for public service, something we certainly agree with, and it's really the reason we got into this mission in the first place, is to provide that high-speed communication to our responders. So just a quick summary, we've talked about some of the features and benefits. Our newest stable release was just as recently as March, but since then, and we have these every once or twice a week, a nightly build with frequent improvements, all of which are very well documented, both on the website and on the GitHub page that lets you know what was fixed, as well as on the GitHub page what is still left to be done, so people can look at and make requests for improvements or address bugs that they think they found. So we're very pleased with what we've been able to accomplish. We've been awarded the Microwave Development Award by the ARRL twice now, once in 2014 and once in 2018. And we hope to keep up with that record and continue our progress over the next few years, and maybe receive the award again at some point in the future. So we're happy with what we're doing. These are just a few of the new features that have come out recently. I won't go through all the details of this, but if you have questions, we can maybe talk about it, or I can point you to where you might find more details of that. And as I said, the important message here is all of the change history of everything that's been changed in the software, and often the reasons why it was changed. All of that's available to you freely on GitHub, and you can go look through that, and it's just, you know, for your interest. So we think Arden is at the center of emergency preparedness. And here again is a group from the Sheriff's Department and responders in the command center being fed a variety of information through an Arden network that local hams have set up in support of their mission. And with that, I thank you from all of the Arden team. I'm Randy Smith, Whiskey Uniform 2 Sierra. You can get a hold of me via the email address at Arden Mesh. And I guess back to you, Dan.
Okay. You want to drop your screen?
Yep. Let's see.
Do it for, I can do it for if you like.
Yeah, go ahead. Yeah, just, yeah. Oh, here it is. I got it. Stop sharing. Yep.
Okay.
There you go.
Cool. There we are. Okay. Let me open up my camera here. And Don, AB1PH, you've had your hand up forever. Did you have a question?
No, you'd asked who had been using the microwave technology like this in the past. And I don't know how to put it down.
Taken care of. Taken care of. Anybody else? Okay, George, KAC2NX. Take it away with your question, please.
Good evening, Randy. Good to see you again. Question that we had addressed, I guess, about a year ago when we were actively pursuing and setting up that deployable video surveillance system. We had some issues with latency, and we had inquired at the time about QoS, quality of service, basically the thing that's going to give you the priority structure for your usage of the thing. Has that been addressed at all by your development team?
Yeah, thank you for the question, George. Good to see you again. I hope to work with you and Dave again sometime in the near future. No, we have not addressed the quality of service. It's actually been under discussion probably since the beginning of the project in 2015. Part of the reason that we have not is that among ourselves, at least among the core development team, we haven't really easily come to a conclusion about what quality of service means and how we might prioritize it. So my recommendation is that if you and any other member of the audience here would like to help us out by starting and leading a discussion of that, or on the Arden forum page, just started to open up a topic on that, and let's see if we can get some conversation going on what does that mean to various people? How would we define quality of service for video streaming versus telephony versus something else? Then we'll see what comes out of that, and then ultimately I would expect that the results would be some set of feature requests that we might be able to incorporate. So thanks for asking, George.
And a second question, sort of related to the same thing. One of the things that I've experienced when working with microcontrollers, particularly when you're using library routines, very often those things are nested many deep and you have no idea what you're doing. You end up with interrupt conflicts. And I'm curious to know if you're dealing with things that are cognizant of the specific processors that are in the devices, or are you basically just writing this entire thing at high level and allowing it to port over to whatever devices? I don't know what processors Ubiquity uses, or for that matter, whether there's something common in this stuff. Is that fairly broad, or is that something that could be addressed fairly narrowly if there's only one particular class of processors that are being used?
Well, thanks for asking, George. The answer to that is there's a number of different small number of different processors that that we support. The broader answer is that all of this has been addressed for us by the thousands of software developers that are writing and maintaining and deploying something called OpenWRT. So if you go look up openwrt.org, that is the actual basis of Arden and actually the basis of the earlier broadband hamnet. And that's where all of the real low-level libraries and the things that actually talk to specific processors resides. So we built on top of that at a fairly high level, and we're able to manipulate a certain subset of the hundreds of devices they support. We can support, we can manipulate the systems on a chip for about 76 devices. 76 devices of the literally hundreds and hundreds that OpenWRT supports. We can manipulate them so they operate in the ham bands as well as the Part 15 things. So your concerns about the low-level interrupts and timing and all of that, that's already taken care of for us by people that really know all that stuff. And our developers have had several conversations at various points with some of those people that write code at that level. So we're also become very good and adept at keeping up with the very latest OpenWRT stable releases, and that's intentional because they're actively maintaining it and putting a lot of bug fixes and enhancements and whatnot into it. So if we keep up with them, then we benefit from all of those thousands of man hours of development.
Thank you, Randy.
Okay, I have a couple of questions here coming on the chat thing. One of them's got concerns about using the internet. The internet goes away, all this goes away. How do you address that?
Oh, that's a great question. Thanks for asking, whoever did. Well, first off, the primary intention of Arden has and still remains among most of the members who are actively using it is to not to have any internet connection at all, because what many of these hams are doing are setting up a private microwave, private internet, if you will, with no connection to the broader internet or commercial services. It's there to be used as a substitute or replacement if all the normal communication channels, including the access to the regular commercial internet, goes down, and yet provides the same ability for responders to use their high-speed communication devices, whether it's cameras or phones or computers. So the internet need not play any role whatsoever in your Arden deployment. Having said that, you do have the ability to connect your Arden mesh network to the internet if you desire. And of course, you can turn that ability on or off at your control. And as you may have seen from some examples, we do have a number of people worldwide who've set up tunnels, in effect, across using the internet to connect places like New Zealand to the US and to the Netherlands and to a variety of other places. And while no one would recommend using those sort of connections for some sort of emergency response communication, they are very helpful in familiarizing local hams with the capabilities of a mesh network, uh, such that it exposes you to a variety of other services and installations. So for education and familiarization, as well as other ham activities, getting familiar with how other people have done their deployments, it's very useful. But it's almost never intended, the internet connections are never really intended to be an active part of a real emergency communication support infrastructure.
Well, thanks. Trying to get the, I hope I don't miss any here. I got a person here, Jared has got his hand up. I'll get to you in just a moment. What do you recommend in areas that have no hill except for a couple of garbage dumps, which are bumps, for this kind of communications?
Well, that's a tough one, because that would cover a significant part of the country, and so the answer to that is, you know, if you look at say a flat part of the country like the Dayton, Ohio example that I have, they're relatively flat, and so they're using the traditional either put up your own tower or see if you can get some space on an existing tower or a commercial tower or a water tower, or we've even had some creative people that know building managers or architects or building owners, landlords who have a taller building in the area. Sometimes you might be able to put it on say the top of a high school or a grain silo. So you've got to look around and see what the high locations are, and then using a tool like Radio Mobile or something else, seeing if that will work for you.
Okay, we'll catch one more here off the list, and we'll go over and get somebody's hands. People got their hands up. How do you address the encryption problem, or more importantly, how do you transmit P11 or P11 data without encryption?
I don't know what P11 data is, but you know, at the moment, all of the data that hams send across Arden mesh radio links, microwave radio links, needs to conform to Part 97 rules the way they would send data using any other tool across any other part of the radio spectrum that's governed by Part 97. So we all know, or we all think we know, what that means. Me personally, and not speaking for the Arden team, but my personal belief is that the rules should be modified. I forget the section 202 or whatever it is that refers to obfuscation. The word encryption is never used in Part 97, but the obfuscation part, I'd strongly suggest that
one group of people. This
the
is truly about our community and making sure that everyone is safe. And the plans are being
could somebody mute, please?
Yes,
Thank you.
please.
Thank you. I'd suggest that encryption be permitted on the microwave bands, you know, from 900 megahertz up. But that's my personal opinion. As far as I know, everybody's that's deployed in Arden Mesh is complying. But again, this is an individual ham's choice to comply with Part 97, as we all know we must.
Okay, thanks. Let's take some of these hands. Gerald, WA2, IWW, I believe it is. Go ahead and ask your question. Jared, are you there?
Can you hear me?
Can now.
I'm playing.
No, now you're broken up. Try it again. Okay, let's leave Jared's hand up. We'll get back to him. N3 ADE, Dave, Maryland, you want to ask your questions?
Sure. How's my audio?
Sounds great.
Okay. Just a comment on something that was mentioned before in flat areas. If you had an emergency situation, the possibility of small aircraft, balloons, and tethered drones comes to mind for communications relays. So just a comment.
Yeah, thanks. That's a great. I'm glad you mentioned that, and I really appreciate your comment on that. There's a ham here on the East Coast, Damon. Trying to remember his full call sign. I think it's K. I think it's a K9. I know it's CQB, and he's based somewhere in Virginia, I believe. But he's among other things, a very creative guy. Among other things, he's done some experiments with an Arden node suspended from a drone. So you're right on the money, and I'd like to see more of that kind of experimentation done. It seems to be a good marriage of some 21st century technology to help out in a situation like that, particularly for all the flatlanders among us.
Okay, if there's anything that hams can do, we can experiment. We get very, we do a lot of things like that. Okay, Bob, K3RF, go ahead.
Yes, good evening. Randy, you mentioned 3 gigahertz is for use in the backbone in your systems. How's the recent loss of that band, or the pending loss of that band, to the Citizens Broadband Radio Service go to affect Arden? Is that a loss we're going to be able to recover from?
Well, we certainly hope so. It's, yeah, as you said, it's pending. So, you know, it is what it is. We fought as hard as we could for that. We're still fighting the challenges to the 5.8 gigahertz spectrum. You may have seen the filings that we put in when there was opportunity to do so. We just signed off on a letter that was a coalition of organizations sent to the commissioners and to the Senate committee chairs requesting that the FCC not do what they're proposing to do with 5.8 gigahertz. So we're actively engaged in trying to protect the spectrum that we're making such good use of. And of course, that's always been the argument. It says use it or lose it. Well, here we've been actively using 3.8 gig and 3.4 gig and 5.8 gig for the best of all possible reasons for supporting public service activities. And so it would be horrible if we end up actually losing that. However, if we do, I suspect that apart from the agony of the monetary loss that individual hams have put into all of this, that if they choose to recover those long distant links, we'll end up putting up some 5.8 gigahertz gear to replace the 3.4 gig equipment, at least to the extent that we're able to. So again, the fight's not over. We're doing what we can. We'd appreciate everybody's support as opportunities arise for you to comment on how best to protect this very valuable spectrum that we are in fact making active use of.
I couldn't agree with you more. As you all know, our league has spent a considerable amount of money responding as well, fighting against it. But I'm afraid that the public service benefit that we all know comes from this type of activity is now overcome by the value of that spectrum in the eyes of the commissioner at the FCC. But we'll see what happens. I'm afraid we might lose 5.8. Well, that's a valuable band, and we're fighting for that as well. Thanks for your answer.
Thank you. Dan, you got your hand up there if I can find you. COO, did you take your hand down, you little turkey? Okay.
Yeah, I did, but there are a couple things here. Are we actually losing the upper part of the 3.4 band, Randy, or are we going to maintain what we have right now, which is secondary to I think it's military use, and the new allocation is going to be tertiary. In other words, we're all going to have to get along together. And the issue of obfuscation versus encryption, I spent an obscene amount of time looking up proposed rulemakings and reading the FCC's findings. And in every case where someone wants amateurs to be able to encrypt something, they include the phrase, because it is not necessary. And there never has, and I'll bet there never will be a case where an agency that needs something sent to another addressee in that agency, which we transmit exactly as we receive, which makes it to the destination, who's going to complain and what would they complain about? We have no reason to encrypt anything more than we do to ensure privacy in our household Wi-Fi stuff. But I'm pretty content that, actually Arden is arcane enough so that if somebody wants to see what's going back and forth, nothing we do or don't do is going to stop that. Just my 3 cents. And are you ever going to come up with a new version of this? I only have about a dozen left. And that's out of a gross.
I'm sorry for the call, folks. Go ahead, Randy.
Oh, I'm sorry. A new version of what? I'm not seeing. I'm just seeing what you're. Oh, the brochure. Oh, you've got. Oh, hang on to that. That's
available on the website. You can print it out yourself if you want.
Yeah, print. Yeah, it's in PDF. This is. I'm not planning on printing many more of those, Dan, because they're awfully expensive, and we kind of sucked up our budget for that.
Okay, and I'm being lazy now, but will Open WRT, is that 802.11n only, or is it the availability of equipment that has thus far kept all the Arden work in 802.11n instead of?
Oh, that's a great question. Thanks, Dan, for asking, Dan. No, OpenWRT also supports 802.11ac, but the issue is one. I'm trying to remember now exactly what Joe told me. I believe that the drivers to support 802.11ac for the chipsets that we can use to get into the ham bands are either not available or through OpenWRT or anyone else, or they can't be jiggered with. So at the moment we don't quite have a solution for that, but that's a little bit beyond the real reasons for it are a little beyond my technical understanding.
And last comment is, on our bedroom deck here, I put up a 24-hour experiment, which was, I think it was running 315 something. It was a rocket. I put it up on May 14th, 2015, and it's still working. I've upgraded it, I think, to 316, and I need to, upgrade it to 3.20 along with the stuff on the hill. But it just happens to work, and it was intended as a 24-hour experiment, and it's still my primary link to the mesh island here.
Well, that's great to hear. Congratulations, Dan. Let's hope it lasts for another 4 years.
Okay, let's move along here. Let's go to W6LIK, California.
I'm relatively new to Mesh Network. Today was my first exposure to Arden, and I'd like to thank you for doing such a thorough job. I have a question. Does the FCC monitor you or check you out? Who makes sure that everybody's in compliance?
Well, as far as I know, individual hams need to make sure they're in compliance. I don't know that, I don't know for a fact that the FCC is doing a tremendous amount of monitoring of ham activity in general, other than to when, the league or individual observers, file a complaint, that somebody's doing something wrong. You didn't ask it, but the one of the requirements of Part 97 is that radio transmitters need to be identified at least once every 10 minutes. And one of the things that's been built into Arden from the beginning, actually built into broadband hamnet as well from before our beginning, is that when you configure the software, the first thing you put into the software is your call sign, and then some other characters to make each one of your nodes, each one of your devices have a unique name. So I might call mine Whiskey Uniform 2 Sierra dash Alpha, and then the second one dash Beta Baker, and so on and so forth. So they're all unique. But that first part of the name of the device with my call sign, that gets automatically transmitted as Part 97 requires, at least once every 10 minutes. So if someone wanted to monitor an Arden configured transmitter and find out who was transmitting on 5.8 gigahertz, it would be easy to do, just like anything else that's compliant with Part 97.
Thank you.
Thank you.
Website, right?
I'm sorry, go ahead. I interrupted you.
I'm going to look at your website. I think you gave us so much valuable information, so thank you.
You're welcome. Yeah, again, it's ardenmesh.org. And for those of you that are interested in the more details about the Southern California mesh network, Don Hill and others, I believe, have put together something that's originally based in Orange County, but it covers the wider area. And they have a website called OC, Oscar Charlie Mesh.org. And they've got links to other organizations there. So if you folks on the West Coast in particular would like to look at that, I commend you to look at ocmesh.org.
Okay, Joe, over in Hawaii, go ahead.
Oh, thanks, Dan. Randy, I'm Joe Sproni, AH0A out in Honolulu. We're starting to play with Arden Mesh in the area. And one of the questions that comes up is the use of 900 megahertz for links. Some of our mountainous areas, it appears to have better propagation. I'm wondering if Arden Mesh is doing anything with 900 megahertz. You didn't show it in your presentation, but you did mention it as a frequency. And related to that is the standard that's coming out of European activity, as I believe, called NPR, New Packet Radio, with 100 kilohertz wide signals on 70 centimeters. Wondering if Arden Mesh is looking at that, if there's anybody who is experimenting with it?
Yes, thanks for both the questions. Yeah, I apologize for failing to mention the Arden does support 4 bands, and 900 megahertz is the 4th band. We're still supporting that. There aren't too many deployments of it, but there may be special cases as you described in Hawaii and elsewhere. So it still works. I'm one of the few people on the East Coast that has any 900 megahertz gear, but it's really more used for experimenting and testing. And I've got a rocket with one of the Ubiquity Yagis, and I've got a couple of their 900 megahertz nano stations, and the stuff that works just fine under the right conditions. So it's still available for people to use. I forget what you had a second question. It's escaped me.
Yeah, NPR is
Oh, NPS. Thank you. Yeah, NPR. Yeah, that was developed by a ham in France, I believe, New Packet Radio on the 70 centimeter band. And our project manager, Andre, K6AH, bought a pair of radios and started to do some experimenting with it. He's been tied up with something else lately. And he's had to put a lot of this aside temporarily, but I think after the first of the year, he'll be back experimenting with it. His initial experiments were promising, but as you'd mentioned, the bandwidth is extremely limited, so you're certainly not going to use that sort of RF connectivity for doing voice over IP telephone calls or certainly not streaming video, but it might be very useful for control links or for short text messages, that kind of thing. So it probably has a place. It's something that's going to take a lot more experimentation and some more community interest to get going, but it's definitely worth looking at.
okay. Thank you very much. Back to you, Dan.
All right. Thank you much. Jared, I see you took your hand down. Did you want to try it again? I see Jerry, but not Jared. Please, everybody, mute yourself if you're unmuted. Okay, let's take a couple. Oh, yeah, Jerry, well, okay. Jerry took his down. Sorry about that. I didn't mean to scare you away. Kyle, go ahead. KC9 SDK.
Thanks, Dan. One of the questions I've got for Randy is here in Wisconsin, we've got a couple of really hot areas that are starting to experiment with the Arden mesh networks, particularly in one of our counties, Sauk County, and it's starting to expand into some of the more urban areas of the state as well. But do you have much experience with typically the higher end bands, the 5.8 and the 2.4 gigahertz, regarding precipitation attenuating the signal, like heavy snow, heavy rain, things like that?
Not me personally, but I do know that some hams have experienced that. I think that would be an excellent question and discussion to have on the forum. I do know that, again, in talking to one of our developers in Southern California, Joe, AE6XE, he mentioned, Kyle, that and demonstrated to us that there's a certain condition where the real heavy fog rolls in. And I see Don Hill is there. Don can certainly attest to that. We get the heavy fog, which is that real thick mist, and it really does drop down the link speeds on certain links, not between all locations, obviously, but just where that fog affects. So it's like any other microwave transmitter and receiver. It says, yeah, rain and snow is going to attenuate. Same way that your satellite dish pointed up from the roof of your house to a satellite so you can get television gets affected by the same conditions. You need to account for that.
Okay, that's one of the main things I had to ask you for. Thank you again.
All right. Somebody was asking here about the use of hobby drones. I use a commercial drone and all this. Okay. Can you comment on the use of drones?
Yeah, Dan, that was actually me. I was responding to Randy's when Randy was talking about tethered drones and balloons and stuff like that. This is Damon K9CQB. I was just responding to the group that Hank, who's commsprepper.com guy, K1DOS, I think is his call sign, and he used his hobbyist drone to get I built a radio for him, or modified I believe it was a nano beam little feed horn, stripped it down and kind of cut the built-in antennas off of it and connected up antenna connectors to it, so you could deploy that. And I also deployed an Arden network on one of these tethered. They call it like a rapid tower or a tethered tower, but it can carry communications gear. It's a fairly large drone that's tethered, and you connect it to power. You roll it out of the trunk of your car, and it just launches in the air 200 feet, and you can keep it up there 90 days if the weather's good before you have to bring it down for maintenance. And they're very expensive though. And I was just helping a buddy test his out. So we had a good Arden link at 200 feet on that. It's actually amazing because it was less than 5 minutes to set up. But this summer when I get the chance, I'm going to put up. I already built small little radios with battery packs up on a tethered Mylar balloons that you can buy. At Party City, you put 3 of them together. They're 36 inches a piece, and you can use packing tape to connect them together, and it'll lift up. I'm hoping I can run a good 6 to 8 hours of a 2.4 gigahertz radio, omnidirectional antennas on there. Bare bones, I've just sprayed it down with waterproof coating that's used for grip on steps. It's like a grip spray for steps. Works really well for waterproofing components like this. Has good heat thermal transfer. So I'm gonna put that on the forum once I make that happen. It'll be tethered with just fishing line, so the whole battery and the radio will be up there. And I'm gonna shoot for about 200 feet, but the whole project will cost me $80 total. Over.
That sounds pretty nice, Damon. Hey, it's great to see you, and thanks for correcting on Hank K1DOS and his experiments. It's great seeing you. Maybe you and the other guys from Virginia and Maryland can put together a couple of trunk loads full of those drones for the next Marine Corps marathon, and fill in some of those dead spots that you guys found.
Yeah, we have Rock Creek Park is a dead spot that we have, and I really wanted to put one up there. The problem is that it's right in the flight zone for Reagan National, and they don't want us to put up anything. I volunteered to put up the balloon, 36-inch Mylar balloon, because it's so small you can't even really detect it. But we just didn't want to get in any trouble at all. You know what I'm saying? So this was probably wise, but I'd be more than happy to send that thing up.
Very nice. Good luck to you. I'm looking forward to hearing the results of all your experiments.
Sounds like the place to go is that forum. It's going to be a lot of information. For those that may be having a problem, find out where to raise your hand. When you look at your participants, you click on the participants. It says 93 in there. It will bring up a list. And at the very bottom of that list is where you can click to raise your hand. And so I had a couple of questions here on how to raise a hand. That's how you do it. And Tom, you get in there? J6ZNY. Hello, Tom. Hello, Tom? No, Tom. Okay, we'll come back to Tom. In 3, AD. Okay,
here.
Tom.
Yeah, fumbling here. if we're unsuccessful in heading off the loss of frequencies, what mitigation do we have on that? Is there, what's our possibility or the probability of restoring them via lobbying? KG6ZNY.
I'm sorry, I don't have an answer to that question.
Okay. We'll come back to that. All right. Let's try N3ADE, Dave and Marilyn.
Hi, audio okay?
Audio's fine, Dave.
Okay, comment on what I guess it was K9 said before, I didn't catch his name, about the Mylar balloons. There's you can get copper coated steel, which has a very light insulation. So despite the weight of the batteries, you could probably use that, 2 conductors there, even with a small DC loss on your line for 200 feet. You could probably use that and manage the weight. And this way you could keep it up longer than 6 to 8 hours if you needed to. Because it's got steel strands, it's strong enough to hold the balloons. You wouldn't have to worry about stretching the copper. And because it's copper coated, you get better conductivity. And it has an insulator so you could string 2 at the same time. I've used it very successfully for small loop antennas, low power QRP stuff, and it's very light. So just a comment, if he wants to try it with power from the ground as opposed to batteries, which add weight.
Hello, Randy.
Yeah, go ahead.
No, okay, there's nothing more there.
No, he was just commenting on the, what was the name of the product again that you were, Dave?
It's a very small AWG gauge copper coated steel. So there's like 2 or 3 steel strands like you'd have in commo wire, the old military style commo wire, but it doesn't have that heavy insulation coating like the commo wire did. So it's much lighter and much more flexible.
Got it. Okay, it's copper, like a copper clad steel wire, but very thin.
Exactly.
Okay, thanks, Dave.
All right. I think Rhea N2RJ has been trying to get in here. Rhea, you want to jump in here real quick? Rhea? N2RJ, did you want to jump in here real quick? She may have left the scene for a little bit. Jerry, WA2WW, could you want to jump in here?
Yeah, how's the audio?
Sounds great.
Oh, fine. I don't know what the problem was earlier. Thank you for your patience. This was a while back, but I wanted to comment briefly on QoS, or quality of service. I've been doing IT for New York State for more years than I care to admit, but basically there's 3 types of network traffic. Real-time traffic is like video or voice, phone, conversation. And the problem is you do not want problems with latency on that traffic. You don't want as little latency as possible, and you sure as heck don't want variations in latency. But what you can do is you can have an occasional bit error and no one's going to care. Because, so 1 pixel is slightly off on the color, or there's a click or something in the sound. We can tolerate that. So what happens is for the interactive traffic, you want low latency, constant, non-varying latency, and you will tolerate occasional error or corrupted packet, or maybe throwing a packet away if things get, out of hand, if you have a buffering problem. The middle ground is interactive traffic, where you're like working on a web browser, you're typing stuff in, and then stuff's coming back. That's sort of the middle ground in terms of tolerance for latency or tolerance for errors. And then the other end of the spectrum is batch stuff like email or file transfers, where you can't tolerate errors, but you can tolerate delays, slight delays or varying delays. So what happens is you have to look at all your traffic and make sure your routers can support QoS, and you have to play with something called the DSCP, which is the Differentiated Services Code Points. And I'm afraid explanation beyond what I just gave you I won't be able to do, but those would be like the areas of study if you wanted to, see if you could make QoS work in an AREDN network. Does anyone have any questions on that?
I wanted to thank you for your comments, Jerry. If anything gets going on our Arden Mesh forum, I hope that you'll log in and respond to them, maybe contribute to the conversation. I think all that's helpful.
I'm not sure I'm that good, but the thing is, in terms of the dictionary definitions, and again, New York State's been running networks for a long time, but QoS is something we did not have at the beginning, and more recently, we've had to do it.
Well, so you've got more experience with it than I have, so that every little bit helps. And anyway, also you bring up another interesting point, coming full circle to what I talked about originally about, very briefly, about network planning. People need to understand if you're going beyond the experimental stage and you actually intend to set up even a very small but somewhat permanent network to support your community responders, like we saw in the Salem, Oregon example, or some others. You really want to understand, why you're setting up that network and what are the expectations of your served agencies. Just as you just described a moment, Jerry, a moment ago, are your served agencies going to do a lot of streaming video and voice over IP telephony, or are they going to rely more on email or document transfer, or what? So you have all of those considerations need to go into your network planning, and that'll tell you what better what direction to head.
Okay. Any comment back on that yet? All right, I'm going to take one from the list here. Do you ever use external PAs, preamps on your longer links? If so, what bands, models, characteristics do you look for? My interest is in the 2.4 gigahertz band.
External power amplifiers? No, not at all. They're all built in to the units, and there's a lot of design considerations that go into what they are and why they are. There may have been a few people that have experimented with the 2.4 gigahertz band, but I don't recall the details, and I don't know that anybody's successful or that there'd actually be any reason to do something like that. The gear as we find it, the commercial gear, really operates quite nicely as long as you understand what its characteristics are.
Okay, super. Everybody's out here trying to help Rhea out. Rhea, are you back with us? You want to hop on here? Nope. There's Marv. He's in there. Got to mute yourself, Marv. I'll mute you. Okay. Let's take another one from the list here. Harvey, go ahead. W8HRB.
Is the audio working?
Looks good. Sounds good.
All righty then. I have in the past used a ham mesh network setup. I flashed 3 Linksys routers, and I was running free PBX, Cisco phones on it, and I was running a NAS unit with a PC, and I was communicating good with everything with it. What I'm looking at is it possible if I switch over to the AmperNet, if I switch over to the Arden, can I use AmperNet to interface with, say, the West Coast guys that are out there?
With the West Coast Arden guys?
Yeah.
I don't think so. I think there are a couple of tunnels set up that you might be able to do that. Is your interest primarily VoIP?
No, I'm like the how would I put it, the techie little geeky guy over here in Michigan in my area that I'm at, and I just like experimenting with different things and seeing if I can get it to work.
what I might suggest is, again, given your prior experience, and my friend Mark Herson, N2MH, who lives in West Orange, New Jersey, here, N2MH. You'll see him on the forums. He's one of our initial Arden ambassadors as well, and our voice over IP telephony expert. He's literally set up a network of worldwide tunnels that, and it runs telephone conference bridges over a combination of Arden networks and internet tunnels. And he's helped people literally all over the world, from as nearby as New Jersey and Tennessee to as far away as New Zealand and the Netherlands, set up PBXs and help configure their phones and their mesh networks. So as one good source for that sort of experimentalist in you, I'd suggest maybe you and Mark ought to get together and have a conversation about things you might want to try, because I think he could get you all fired up about a lot of different things.
Alrighty then. Thank you very much.
You're welcome. Thanks for asking, Harvey.
Yep.
I like connections like that. That's cool. Okay, WB2 SFEF. I'm sorry, in Arizona. You want to take it?
Sure. Am I there now?
You're doing good.
Great, thanks. And Randy, thanks for putting on today's show. I certainly appreciate the insight and giving everybody exposure to Arden. One of the things I do is I'm on the MCOM side of things, and I've looked over the number of years at all the projects that have come along. I've actually started doing IP networking back in the 80s over packet, right? Yeah, so it was the old KISS versus AX25 discussion in the day. So it's important to me that the data paths work and are available in the MCOM space, but there's a couple of things that bother me. I mean, Arden has a thing that says emergency in the middle of it, and I appreciate it being a dynamic capability that you can stand up if needed. In that sense, emergency makes sense. But when people see it, they want to talk about integrating into the EOCs or into the command vehicles or command posts. There's a lot of concern about some of the things like encryption, things you don't want to pass. Also accessibility into that network, that if you extend the network into the MCOM environment, that is perceived as problematic. So there are a couple of things. We talked about QoS. That's important, right? As we just kind of heard, that making sure I can deliver the things I need to deliver. So bandwidth reservation and quality of service are important qualities when you're implementing and designing that network. Another piece that I'm interested in is, does the Arden implementation support things like VLAN or network segmentation, where we can isolate components within the network as it's happening? Do you know if that exists as a capability?
Yes. Yeah, thanks for asking, Michael. Yes, I'll answer your second part for yes. The VLANs are an inherent part of what we're doing. If you look at the documentation, there are 3 VLANs set up built into the software intentionally for specific purposes. And I won't go into the technical details, but yeah, the concept is supported and really required. Going back to your earlier comments, thanks for raising them. I think really what you brought up to the group here is the very real life concept that one size does not fit all. And you know, Arden as a project is not intending to dictate the results to anybody, much less even lead the conversation, because all of you in different parts of the world and your localities have different needs, different sets of requirements, different served agencies, different resources available to you, and all of that goes into the mix. So that's when we talk about network planning, you know, people tend to start and stop with, do I have space on it? Do I have enough towers to put stuff up high? Do I have enough places to deploy the local units? And they're interested in the technology. But Michael, what Michael's bringing up is really all the other very, very important considerations for network planning beyond the technology and the RF path planning that have to go into your conversation about why are you doing this here? You know, who are you helping, and are you really going to help them if you don't understand what their needs are, what their requirements are, and even more importantly, what their limitations are. So, you know, before you start committing to helping out the local Red Cross or the local fire department or local hospital, you need to have some real serious conversations with people so that you're actually helping and not becoming a nuisance. Thanks for bringing up all of those points, Michael.
Yeah, you bet. And thank you. I've had real world experience where I love cool toys and I love the experimentation and the things that are going on. But I've had a local Arden implementation group start up and started with the voice over IP phones. And they said, we can put a phone in the EOC so that we can call you. And the EOC manager said, you'd have a phone here. And would you publish that phone number? And the answer was, oh yeah, we've got a directory. Huh? You would publish the phone number. So, and we build these VPN tunnels to New Jersey. Oh, so I got a guy in New Jersey who's going to call my EOC to ask what's going on in the middle of, sorry, have a nice day.
Yeah,
so
exactly.
So you can't even get
that's
past
what I
that.
mean about you got to understand the local requirements and the local limitations and not fall in love with the technology so much that it blinds you to all the, you know, what the real world work that real world people are trying to do. You don't want to get it. The whole point is not to get in their way. Provide communications and get the heck out of the way. But
And
provide communications that they actually want.
Right, that's exactly right. Solve a problem, right? And if you can solve the problem with the tool set, then you bring value.
Yeah,
and
solve a problem, don't become the problem.
Correct. One of the features that is high on our list is the ability to block users of the network from being users of the network if needed. In other words, we've got stuff going on and somebody spins up a 4K video stream in the middle of the world. And I would be able to isolate that consumer off the network to continue doing the business at hand. That's a feature set I'd like to be able to know is there, and that would give some comfort to those who want to implement it if that management capability was around. And I don't know if it is. Maybe it is.
At the moment, it's not. There's been a lot of well, not a lot, but there's been some discussion of that over the last year or so. So it's a feature set that needs to be developed. And of course, like any other feature set, you know, we need to understand what the real requirements are and how those requirements will end up translating into actual operational code. But, you know, if you want to get some conversation started on that subject, that very specific subject, either on the forum or as a request in GitHub, I'd certainly appreciate seeing it, Michael.
Yeah, you bet. And thanks for having the conversation and allowing us to take it further. I think that there's a lot of potential here. We just have to keep it in two sides. Like you said, there's the experimentation, there's the build, the great data path, the RF components, but you got to use it, right? And if otherwise it's a build it and they will come and they may not. So thank you.
Well, thank you, Michael.
Okay, Dan, looks like you got your hand up again.
Yeah, a couple points. This most recent commenter, I think Arden is best perceived of as circuit providers rather than a bunch of hams insinuating themselves into your EOC. And that's really where it shines, and how you make use of it obviously has to be up to your needs and your internal policies. And the gentleman a couple of comments ago who I thought he asked about AmperNet and VoIP. And something that hasn't come up yet is that ardenmesh.org allows you to subscribe to any topic you want, either to see individual messages as they surface or digests. And one of the many subscriptions I set up 4 or 5 years ago had to do with 44net. And just in the last 72 hours, there was some conversation about that in one of the digests that I opened up and didn't take the time to read. So if you go into the ardenmesh.org and search for AmperNet, you're going to find out a whole lot about it. That's all I wanted to say. And the feature to search ardenmesh.org for the specific areas you either can't figure out what to do or you have particular interest in is invaluable.
Yep, thank you very much for bringing all of those comments up, Dan. Yeah, there is a tremendous breadth of information available on the website. I mean, it blows me away completely. There's all kinds of topics that are up there. So do what Dan says, go look at the search bar and stumble around, if you will, have some fun and see what you can come up with.
Okay, Rhea, looks like she finally found her raise the hand button and she's there. Rhea, go ahead and take it.
Yeah, I did. I was actually on a phone call. Apologies if this is a duplicate question, but I know Bob asked about the spectrum and the future of Arden and stuff like that. One thing that was brought to my attention was that, is there any consideration to using other types of links besides the Arden mesh for backbones and long haul links and stuff like that? I'm talking about things like D-Star and other data technologies. Apologies if that's been asked already.
Well, I can't say that there's been any other considerations of using alternative technologies for long distance backbone links other than commercially available links using equipment similar to what we're using. So there's been some consideration, some experimentation with that, but not things like D-Star. I'm not sure what else you might be referring to, but nobody that I know of has considered that.
Okay. Yeah, because it would seem to me like for some purposes that D-Star might be a good way to kind of like bridge gaps that you can't really bridge with the existing Arden system. Like say you don't have like a commercial connection, 1, and 2, if you're using microwave frequencies, there might be some path issues and such like that. But,
well, we did have a brief discussion earlier about new packet radio that operates on the 70 centimeter band.
Okay.
That was developed by a French ham, and our project manager, Andre K6AH, had started some experiments with that. And as I pointed out earlier, they're interesting, but one of the severe limitations is that the RF links in that spectrum only support something like 100 kilobits a second at best. And so while it is useful for some sorts of data communication, it would not support the full spectrum of high-speed data communication that you would do on the rest of the Arden network. So if you could limit traffic, say, to something maybe like email, I suppose, a little burst of file transfer, that would work, but streaming video and probably telephone calls wouldn't work. So there's been some consideration, and it's still very early days.
Yeah, you could probably support a single telephone voice circuit.
I don't know. Well, we don't know. It will, again, this will take some time to develop. Also, the 2 units that Andre got plus the necessary antennas was a considerable expense. So it's not the kind of thing that we're going to see everybody running out to get overnight, although it would be nice to have a few more people experimenting with the technology and reporting back how it might be integrated.
Yeah. So Gordon Gibby just said in the chat, 56K should easily carry voice, and I agree with him. And I'll go one further. If you're using something like I think it's G729, you could use as little as 8K to carry voice. But anyway, all right, I'm rambling way off the topic. Thank you very much, and thank you for an informative presentation.
Thanks for being here, Rhea. I appreciate your support.
Okay, thank you, Rhea. Kyle, you want to get in there and say something?
Yeah, Dan, I actually have a response to Rhea. One of the things that we're looking at here in Wisconsin to do to kind of connect some of the little pockets of Arden that we have across the state, because there's significant distance between them, and they don't want to use commercial internet because that kind of defeats the purpose of it, and they wanted to have more of a reliable connection. Is we're actually in discussions with using FirstNet routers and the FirstNet system that AT&T has been installing across the state as a backbone to connect those two pockets of Arden mesh networks together.
Ria, did you have a comment?
Whoops. Okay, I was on mute. Okay, that makes sense. FirstNet. Okay, so are you just using the FirstNet equipment, or are you using the FirstNet network itself?
Actually, both. We'd be using, I believe it was their cradle point endpoints on either side, and then just traversing the network. Our nonprofit arm for Wisconsin Aries Races has FirstNet authorization, so we've got that backbone for some of our repeaters across the state as well. So we were just, and there's plenty of additional bandwidth that is available to us that our SIP connection for our repeaters doesn't eat up. So, you know, the Arden mesh fits into that slot quite nicely.
Right. So Damon, I don't know how you pronounce the name, K9CQB actually answered my question that the ICOM ID1, he used it in Arden network as an experiment. So that's pretty interesting.
Yep, that's I'm learning as much from the audience, Ria, as they might be learning from me. I'm probably on the better end of the deal here. I don't know how much I'm contributing to their understanding, but thanks for the update, Damon. I really appreciate that.
Yes, and that's what these things are supposed to be about. Dan, you have your hand up again. Got another comment?
Couldn't lower it fast enough this time. So the 8K per high quality voice circuit goes way back in time to when they sliced and diced copper pairs and realized that they could multiplex many solid voice conversations with just consuming 8K of potential. I mean, all the long haul stuff was, I think, telco T1s to start with. And I don't know if I forget how the math works out, but it's a whole lot of 8K circuits. And you can even do it on unconditioned lines, just regular old fashioned telco 24 gauge copper or 26 gauge. What was the other point? Oh, so WinLink Express uses RF modes, and we all know that there are agencies that rely on it using their own frequencies, not Part 97 frequencies, but it's the same encoding and decoding in both instances. So the whole thing about, and this goes back to the, it not really being anything more than a circuit for the EOC. And with regard to FirstNet, having lived with AT&T, well, tried to live with them professionally for several decades, as a major supplier, you want to make sure you read the contracts really carefully and that it's going to stay within FirstNet no matter where it comes from and goes to. Because AT&T is a provider of convenience, I'll say. And just caution is all I would recommend. I don't know the specifics, but I do know that when I started looking at it, it didn't take me long to not be so very impressed. So, and I apologize if that's out of place, but it's it comes from decades of being in meetings where somebody in AT&T at one level promises something, and then as the project spreads out, you find out, oh, what is it this contract says? No, we can't do that, but this is what we're going to do. So, okay, sorry.
No, don't be sorry. You're doing fine. It's getting late. The poor guys in the East Coast have got to be holding their heads up with a pencil or something here. Are there any more questions? Anything we have not addressed?
I I have something, but a lot of people may not be interested. Somebody mentioned T1s a couple of minutes ago. If he wants a refresher on T1 structure and 8 kilohertz versus 4 kilohertz and all that stuff, I could do that after everybody else is gone. You know, as I said, if any, it says that not everybody's going to be interested in that, and I'm figuring we could just put that for very last.
That will draw it out quite a bit longer, and we're going to have some people, including myself, fall asleep here.
No, it'll only take a minute, but we can put it off till the very end.
All right.
Jerry, if you start up with that, I'm going to counter with regaling you all with how I used to set up drum cards for an 029 key punch.
Don't forget the 026 key punch.
Right back at you, bud.
Yeah, 026, 029, we remember them both.
Yeah, enough of the history. We're in the 21st century now, Jerry. 21st century, bud.
No, Jerry, notice nobody's mentioned hysteresis or jitter. And
oh, well, we haven't heard, you know, it's been a few years since we've had to worry about that.
Okay,
yeah, it's been a few years since I wanted to worry about T1s. Unfortunately, when I retired, I stopped worrying about them.
All right, let's get on back here to the subject. Kyle, you get your hand up.
Yeah, I didn't want to just step on everybody, so I figured I'd throw my hand up there. First of all, Dan, thanks for the heads up on the FirstNet. That's always a good thing to keep in mind. I also sit on one of the subcommittees for the state for interoperability, so I'll make sure to look at those contracts a little more closely as a result. Experience does teach you things. I also wanted to applaud you, Dan, for putting this and the WinLink ones together in the same week here, back to back, because the two actually do complement each other quite nicely, with the ability for the Arden net to have access to the internet, even if it's just a one-way gateway. You can use that WinLink telnet link, so you can use the mesh to actually traverse WinLink traffic as well, which is an awesome. And Dan was started to hit on it, and I wasn't sure if he was going to finish it up or not, but they're very complementary technologies and methods of passing traffic, and it's a great thing you did there.
Okay, not a problem. We'll discuss WinLink tomorrow in big length, and I'm sure we'll touch back on some of this stuff too. Then you got your hand up again. We're trying to wrap this up.
Just a real quickie here. There's this nice little WinLink training net. It's not really training, but it's a decent NorCal WinLink net where you can just use a template and send in a message just to make sure your gear's working. There's a little bit of competition in how many modes and how many digipeters and how many routes you can take to get something through. Well, the very nice and effective and congenial developer of the template forms modified the template. And so among your WinLink modes you can select from, there is now an Arden WinLink, Arden Telnet mode, separate from Telnet mode. And it works exactly like Telnet mode works, but it gets you, your first hop is through a Part 97 provision Arden circuit to a gateway. And it's one way in the sense that nobody's going to be able to call you. Well, actually, that's not true. With the VoIP phone systems, you can't have direct inward dial VoIP for phone connections into the mesh. But WinLink, you know, acts and sends you back stuff from the central message server when you make the connection. So in that sense, when used by WinLink, it is a bidirectional gateway to the internet. I'll just leave it at that.
Okay, Randy, you take it.
I'm not sure what I'm responding to here.
Okay, that's okay.
Was there a question in there somewhere?
It was more of a statement, I think. And
that's what I thought so too.
Okay. Are there anything else here that we have missed? Any comments in the chat that we have missed? I don't see any, but we might. Okay, if there are none, I think I want to start wrapping this up. There's 4 guys on the East Coast. but thanks